There is another way we can look at Bitcoin as an application platform. The key features of the Bitcoin blockchain, such as programmability, transparency, immutability, integrity, accountability, auditability, decentralized consensus, timestamping, security, direct peer-to-peer interaction, and open-source nature, among others, can enable a large range of applications beyond payments. Bitcoin was originally designed as a payment system, but the baseline technologies that power it open up much broader use cases. While users of the system see accounts, balances, payments, and wallets, there is a fundamental technological layer underneath. This architecture and its building blocks can be used to create many other useful applications on the Bitcoin blockchain. Let's have a look at a few examples. Digital notary and asset registers. The blockchain properties of Bitcoin make it a perfect system for demonstrating proof of ownership. Blockchain technology can be an effective and efficient solution for real estate property registers, shareholder registers, and other investment securities registers. It can be used to register the ownership and transfers of any kind of asset or property rights, including intangible property like trademarks and intellectual property. Such implementations can be realized through separate, dedicated blockchains, but the Bitcoin blockchain can be used as well. And the Bitcoin blockchain has some clear advantages over any other alternative blockchains. It is the most secure, the most immutable, and decentralized one. This is the case because it is the first and foremost successfully operating public blockchain and has the largest pool of computing resources securing its decentralized consensus system. In this way, assets external to the blockchain can be digitalized and traded on it, in addition to intrinsic assets, such as bitcoins. Another use case for which blockchain is perfectly suitable is trade finance. Imagine that a retailer in Europe wants to import and sell merchandise from China. For example, consumer electronics like TVs, refrigerators, microwaves, and so on. The retailer orders the merchandise from the manufacturer, which then needs to be loaded on a cargo ship and sent to Europe. Both parties to this transaction need security and assurance that they will get what they expect out of it. Travel times for ships to deliver goods from China to Europe are around 1 month. This raises counterparty risk that one of the parties may not receive its fair share of the value exchange. From the perspective of the vendor, in this case the Chinese manufacturer, they need to be confident they will get paid before they load the merchandise on the ship, because at this point shipping costs start getting incurred. The merchandise is also at risk of being stolen or otherwise compromised while in transit. From the perspective of the buyer, the European retail company, they need to be confident they will receive the merchandise safe and sound before they release the payment to the vendor. This type of international trade transaction is currently managed by trusted third parties such as banks. International banks offer trade finance services like escrow accounts and letters of credit. The way the system currently works is, the buyer deposits the funds for the payment to the vendor in an escrow account held at a bank. The bank then issues a letter of credit to the vendor guaranteeing the funds are there and will be released upon successful delivery and receipt of the goods. The problem with this is that such middlemen can position themselves as gatekeepers at strategic points in the business value chain where they control access to the flow of economic resources. If intermediaries are very large organizations, they may end up monopolizing the control over trade channels and be able to extract much larger value from the economy than the value they create. This scenario is defined in economics as rent-seeking. You can probably see how trade finance services can be automated with a single smart contract on the blockchain. This new technological paradigm will render such transactions much cheaper and more efficient. A single technological interface will facilitate direct interaction between buyers and sellers, thus eliminating any potential rent-seeking behavior by intermediaries acting as gatekeepers. Moreover, this interface can be a public, open-source technology such as the Bitcoin blockchain, which is not controlled or owned by any single third party. Let's have a look at yet another blockchain use case, crowdfunding. The crowdfunding use case can be enabled by smart contracts releasing funds to the project upon reaching certain milestones or targets. These can include successful delivery of the product to the market or achieving certain level of revenues or profits. In this way, blockchain can be a viable decentralized alternative to Kickstarter or other existing startup funding platforms. Funds can be locked in a smart contract and released at stages upon meeting certain conditions, in this case, the project receiving milestones. Again, the Bitcoin blockchain can provide the transaction protocol infrastructure to implement such solutions as second-layer technologies with user interfaces on top. Again, these are not just hypothetical use cases and applications. There are projects that have been developing such solutions already for a few years. One such application is called colored coins. The term comes from marking or coloring a nominal amount of Bitcoin to represent something more than the amount of digital currency itself. Colored coins can serve as a certificate of ownership of any kind of asset, commodity, or property. They use Bitcoin transaction scripts to encode and store additional data related to such other assets or properties. This additional data is called metadata. When colored coins are created or issued by inserting the relevant piece of code in a Bitcoin transaction, this registers the external asset on the Bitcoin blockchain and creates an asset ID with timestamp. When such colored coins are transacted on the Bitcoin blockchain, this effectively transfers the value and ownership of the external assets associated with the colored coins. Another similar project is the Counterparty Protocol. It is a secondary protocol layer built on top of Bitcoin. Like colored coins, it enables digitalization of ownership rights and transfer of any kind of external assets. It also features a decentralized asset exchange and smart contracts. The Counterparty Protocol, in turn, can serve as a platform for other applications to be built on top of it, using its additional functionality and the security of the underlying Bitcoin blockchain. Okay, now, time to summarize. In this section, we provided an overview of the Bitcoin blockchain as an application platform. Its programmability enables the creation of smart contracts that can automatically execute business logic and be applied in a wide range of industries and markets. It can also be used to create digital tokens, representing any type of physical asset from the real world. In this way, such assets can be traded easily and value can be transferred. These transactions can be implemented with smart contracts, thus enabling complex transaction structures to be programmed and executed automatically. The Bitcoin blockchain enables all this to be done in a direct peer-to-peer, highly secure, fast, and cost-effective way globally.